Alright, what's going on, guys? So again, terrible lighting. Hopefully you guys saw my last video and realized why my table just didn't come in. But anyways, let's go ahead and find dy dx here. So we're using implicit differentiation. We have two separate y's, so it's kind of impossible to just solve for y. So that's when we use implicit differentiation here. At least that's one of the reasons. But first things first, we take the derivative of x, which is just going to be 1. So we're just left with 1 plus. And when we take the derivative of y, it's going to be 1, but every time you multiply, or every time you take the derivative of y, you have to multiply by dy dx. So even though the derivative of y is 1, we multiply by dy dx, so we're just left with dy dx. And then equals to the derivative of cosine y, which is negative sine y. And then it's chain rule, so we have to take the derivative of y, which is, again, 1, but we have to multiply by dy dx. So essentially what we're left with is 1 plus dy over dx is equal to negative sine y, and then dy dx. Okay, so we can move, I guess we can just leave the 1 on the left side here. What we could do is just move or subtract the dy dx over to the other side. So we're just left with 1 is equal to negative sine y dy over dx minus dy over dx. And now we can go ahead and factor that dy dx out. And we are left with negative sine y minus 1. And then we can divide by that. So what we have is dy over dx. And we have, we're going to write the denominator first, and then minus 1 over, over the, or right below the 1, and this is our final answer. Some answers might have it as dy dx is equal to, and they have the negative on the outside, and so what that does is just changes the sine y plus 1 instead, and over 1, so that could be the final answer as well.